Hi and welcome to the third episode on Redox Reactions with Mickey G. And today we'll just begin with a quick summary of the definitions that relate to reduction and oxidation that we've covered so far. And then we'll move on to some new definitions and how they apply to both organic chemistry and biochemistry. So by the end of today's session, you will have all the definitions that relate to both reduction and oxidation. In addition, I'll also include many more examples of where you'll actually see this both in chemistry and biochemistry. And we'll also finish off with some review questions so that you could actually test your understanding. Okay, so let's begin with a quick summary table of where we currently stand. So with regards to reduction, if there's a decrease in oxidation state, that is to say if the oxidation number of an element drops, that is termed reduction. So how is this achieved? By gaining electrons. Okay, let's now have a look at oxidation. So oxidation is the opposite of reduction, so we would expect to see an increase in oxidation state. How does this occur? Through the loss of electrons. Great, so here are your first two definitions. Now in your textbooks, by far the most common definition for reduction is the gain of electrons. And by far the most common definition of oxidation is the loss of electrons. The reason why I've included the first definition is to help to explain to those students that may be having problems understanding oxidation and reduction that if we look at the oxidation state and there is a drop in oxidation number, this makes more sense because clearly a drop is associated with reduction. So drop in oxidation state, reduction. How does this occur? Well, it needs to gain negatively charged particles. What are these negatively charged particles? Well, they're electrons. So by using this definition here, I'm hoping that it will help students understand why reduction involves a gain of electrons. Okay, so now let's have a look at a third definition for reduction. And this involves gaining hydrogen. While oxidation involves the loss of hydrogen. So a very basic example, let me just correct that spelling error there. So a very basic example would be looking at an organic molecule such as ethene. And here's the molecular formula for ethene. And ethene can gain a hydrogen molecule, i.e. 2 hydrogen atoms, to give C2H6. So clearly ethene has gained hydrogen to become a new compound, and this compound here is known as ethane. So clearly if we look at this example here, ethene has gained hydrogen, so we could say that ethene has been reduced. Now, we can also remove hydrogen from ethane to get us back to ethene. In this particular instance, we're moving from C2H6 back to C2H4 by losing hydrogen, and this would be known as oxidation. So gaining hydrogen is known as reduction, while losing hydrogen is known as oxidation. This may seem strange because currently all we've spoken about has been the movement of electrons. Well, in fact, we're still using electrons. They're just hidden amongst the hydrogen atoms. So what's happening here is this molecule here is not just gaining 2 hydrogen atoms, it's actually gaining the 2 electrons within those 2 hydrogen atoms to become reduced. Equally speaking, when we look at ethane here on the right, it's not just losing 2 hydrogen atoms, it's actually also losing the 2 electrons that come with those 2 hydrogen atoms to become ethene. So in essence, it's being oxidized. So the way I like you to think about this, both in organic chemistry and biochemistry, is think of the gaining of hydrogen as the same as the gain of electrons, and the loss of hydrogen as the same as the loss of electrons when it comes to both reduction and oxidation. Now, there is also a fourth definition. Reduction is sometimes defined also as the loss of oxygen, and oxidation is defined as the gain of oxygen, which makes sense because we are using oxygen or OXI within the term oxidation. So you would expect somewhere to see a definition that involves oxygen. So the gain of oxygen is known as oxidation. So here's our fourth definition. So an example could be any combustion reaction that involves oxygen would be known as oxidation. So if we took magnesium and reacted that with oxygen and formed magnesium oxide, that would be an oxidation reaction. And here is the balanced equation for the oxidation of magnesium. Equally speaking, we could look at a compound that loses oxygen, like for example mercury oxide. So mercury oxide can decompose and lose oxygen to give mercury plus oxygen. And if we balance this equation, and there you see it, oxygen's now been lost by mercury, so that would be termed as a reduction equation. So in summary, you have 4 definitions of both reduction and oxidation, 3 of which are common within textbooks, and the 3 that are common are 2, 3, and 4. The first one is a definition that I use just to help introduce reduction and oxidation to students that may not feel comfortable with the standard definitions, and of course then expand onto the other 3. Okay, so what we're going to do now is look at some typical questions that you may be asked in an examination or a quiz. And I'd like you to have a go at these questions, and then we'll work through them together to see how you fared. Okay, so here are 6 questions that relate to this particular learning check. Pause the video, attempt the questions, and when you feel comfortable with your answers, click the play button and I'll go through each of these questions individually to see how you fared. Alright, with question number 1, we can clearly see that copper starts off with a +2 oxidation state and goes down to 0. It's achieved this by gaining electrons, so clearly this is an example of reduction. That is to say that copper has been reduced. Sulfur, on the other hand, starts off as -2 and goes up to a neutral value of 0. It's achieved this by losing 2 electrons. So it's lost 2 negative charges, gone up to 0. So this is known as oxidation. Here we've got a molecule. It's C2H2. It's gained hydrogen. And gaining hydrogen is known as reduction. This one is also a reduction. The only difference is that we've got this molecule here, which happens to gain a further 2 hydrogen atoms. So it's been reduced. The next, question 5, is a little bit more complicated. We've got ethanol here, which you probably know as alcohol. Now, in order to work out what's happening here, you've got to count the number of each of these atoms. And clearly we've got 1, 2, 3, 4, 5, 6 hydrogens on the left. On the right, we've got 1, 2, 3, 4. So it's lost 2 hydrogens. The loss of hydrogen is known as oxidation. And this is exactly what happens to alcohol when it's left uncorked. Like in wine, it starts to become oxidized and it produces this intermediate compound which is known as an aldehyde through a process known as oxidation. Okay, this is a coenzyme that you'll come across in biochemistry. It's called NAD, stands for nicotinamide adenine dinucleotide. And in this particular example here, you could see that it starts off as NAD with a positive charge, but goes down to NADH. Its charge has been lost by gaining a hydrogen. So clearly here, NAD has been reduced. So this is an example of a reduction. And in biochemistry, you'll probably see an example of when ethanol gets together with NAD plus to cause the ethanol to become oxidized while the NAD becomes reduced. So I'm hoping that these questions or these learning checks have been useful for you in helping to consolidate the information that was covered in these last 3 episodes. If you'd like me to produce some more YouTube tutorials on oxidation and reduction, maybe to do with biochemistry as opposed to pure chemistry, by all means send me a message and I'll see what I can do for you. Thanks for listening.